Today we're going to be talking about how to write quadratic equations from solutions and from the graphs. And it might be a little confusing at the beginning, but really what this is just going back to multiplying polynomials. And so if you're a little uncomfortable with that, I would go ahead and review your notes from multiplying polynomials. And one quick thing I want to remind you is that when we talk about zeros or solutions, that's when our x equals that number. But when we're talking about factors, our x plus whatever the opposite sign of that zero is. So the zeros and the factors have the same numerical value but opposite signs. So let's get into this. If we know the solutions of a function, we can use the solutions to write a quadratic equation. How we do that is by following these steps. First thing we're going to do is write the solutions or zeros. So that's the x equals solutions or zeros as equations. So like if we have if x equals -3 and x equals 1, my zeros were -3 and 1, you write those as an equation. Next, you set the equation equal to 0, just like how the example provides, x plus 3. What we did is we moved that 3 over, so x equals -3. If we want to set that equal to 0, we add 3 to both sides, so x plus 3 equals 0. That then becomes our factor. So we write the equations as factors, shown as the example, and then we'll multiply the factors and simplify. So I have two examples here we're going to do. My solutions are x equals -5 and x equals 8. So the first thing is to write them as equations. We already have that. So now we need to set them equal to 0. We want to get them equal to 0. So if I move that -5 over, x plus 5 equals 0, because that's plus 5 on both sides. Sorry, that was more of an S. Same thing with the 8 minus 8. So x minus 8 equals 0. These are what we're going to use as our factors, and we're going to just set them up to multiply. So x plus 5 times x minus 8 equals to 0. Now we multiply. This is multiplying the polynomials. I'm going to use the FOIL method. So first, x squared. Outside is x times -8. That's -8x. Inside is 5 times x. 5 times -8 is -40 equals 0. Okay, now we need to simplify. Let's simplify these like terms. X squared minus 3x minus 40 equals 0. And if we're writing it in the equation, instead of writing 0, we would write y, or f of x. But it's just wanting it in standard form, so we can leave it as that. So that is our answer. That is standard form. Number 2, it says write the quadratic function. So this is where we'll write it as y equals. But we have zeros at -4 and 2. So that means we need to set them as an equation. X equals -4 and x equals -2. Set those equal to 0. I'm sorry, not -2, just 2. Set those equal to 0. So x plus 4 equals 0 and x minus 2 equals 0. Now we're going to multiply them. X plus 4 times x minus 2 equals 0. FOIL method again. X squared plus, minus 2x plus 4x minus 8 equals 0. I just did the first terms times the outside terms times and then inside terms, then last terms. So simplify that. That's x plus 2x, x squared plus 2x minus 8 equals 0. We want it in the function, so y equals x squared plus 2x minus 8. That is our answer. So that is writing an equation from the solutions. But sometimes you might have the graph, and also you might have a coefficient or an a that's greater than 1, and it either causes shifts or stretches, all of those different ways that we could transform quadratics, and so sometimes we need to calculate that, and that's what we're going to do. So any quadratic equation in the form of y equals a times x minus r times x minus s. We'll have zeros r and s, so that's just where we put in our numbers, where a is a constant. Therefore, to write an equation to match a specific graph, we will need to solve for a as described below. So this is when you're using a graph. When you're actually calculating from a graph, this is what you're going to want to, the steps you're going to want to use. They're just a little bit different than from the solutions. If you have the solutions, you have no idea if there's going to be a different a, so you can't really solve for those. So if you've got just the solutions, just the zeros, that's when you solve for this. But if you're given a graph, sometimes you're going to have to look for the differences. Is it going to be the same width as the parent function? Is it going in the same direction? Those are the things that we're going to look for. So the first thing you have to do is determine the zeros or the solutions from the graph. Number 2, you're going to use the zeros to write the equation. So this is going to be the difference, is we're going to write the equation a little different. It's going to be y equals a times x minus r, x minus s. Remember, those negative signs are those subtractions between the r and the s. That means change the sign of your zeros. Step 3, we're going to find another point on the graph and plug it in for x and y. So this is a lot like what we did previously when we were looking for that coefficient before. We picked a point, we solved for it, and then we used that to write our equation. So solve for the equation for a, and then plug in the value of a and convert the equation to standard form. Sometimes we're not going to have to write it in standard form. I'm not going to write it in standard form in these two, which I already gave away my points, but it's okay. So looking at this graph, our first step is to find the zeros, or where it crosses the x-axis. So I have 2 of them. I have one here and one here. So my zeros, my solutions, are x equals -3 and x equals -1. So those are my solutions. Those are my zeros. So now I'm going to write it into the step 2, this equation of y equals a times x minus r times x minus s. So y equals a, x, negative sign means really change the sign. So if I have a solution or a zero of -3, negative and a negative make a positive. Same thing here, x plus 1. So now we're set up to pick an x and y to solve for a. I'm going to try to find an easy number. I like this one because I know one of my numbers is going to be 0. That point is at 0, 3. So I'm going to use 0 for everywhere there's an x and 3 everywhere there's a y. So 3 equals a times 0 plus 3 times 0 plus 1. And now we're going to simplify. 0 plus 3 is 4. We do 0 plus, that's skipping ahead here in my brain. 3 and 1. We do what's inside the parentheses first. Now we multiply. 3 equals 3a, because 3 times 1. And solve for a. We want to get a by itself, so that 3 and the a are right next to each other. That means it's multiplying, so we divide to get rid of it. 3 divided by 3 is 1, so a equals 3 divided by 3 is 1 again. So we actually don't have to write the a here. So when we write this equation, y equals, I'm not going to put the a, x plus 3, x plus 1. Now I'm going to solve it, and just like how we did in the first group, I'm going to multiply these polynomials. So y equals first term, x squared, outside term plus x plus 3x plus 3. Simplify those middle terms. Y equals x squared plus 4x plus 3. So that is the equation for that graph, and we didn't have anything too crazy. Okay, one more example before we're done. Here's our zeros. we have 1 of x equals 0 and x equals 2 from our graph. That's where it crosses the x-axis. So I'm going to set it up in that equation of y equals a times x minus r, which would be 0, so plus 0, and x minus 2. So I'm going to pick a point. I like easy ones. I can do this one right there. That's our maximum I'm going to use. That's 1, 2. So everywhere there's a y, I'm going to put 2 equals a. That's what we're looking for. And everywhere there's an x, I'm going to put 1. 1 plus 0, 1 minus 2. Do what's inside the parentheses first. 1, negative 1. Multiply 2 equals negative 1a. So we're going to get rid of that negative 1 by dividing. So a equals negative 2. So I'm going to rewrite this equation of y equals negative 2 instead of a. And then go back up to the top, x plus 0 and x minus 2. Now I'm going to simplify by multiplying. I'm going to multiply the two factors first, and then I'll multiply by my coefficient. So first terms, x squared, outside terms is minus 2x, times 0, that's plus 0, and then 0, last term also 0, so I'm not going to write any more of that. Now I'm going to distribute my coefficient. So y equals negative 2x squared plus 4x. That is the equation from this graph. And that is writing quadratic equations, and that is the last lesson of this unit.